This video will cover the last two problems of section 4.4, and the last topic that we did not cover, well, one of the last two, was the half-life. And for half-life, we're going to use the formulas that are provided here. And let's go ahead and establish what each variable represents. So t is going to equal the time, represents the time. H, the variable h, represents the half-life, and I'll talk more about it in a minute. And we also have y sub 0, and so that's going to be the initial value, or also the output of the function at 0, or at t equals 0. So the half-life of a substance is going to be the amount of time that it takes for a given quantity of the substance to decay to 1/2 of its original mass. So for example, if you have 100 grams of carbon-14, and we will use that one because that is the isotope of carbon that is commonly used to determine the age of fossils or human remains, or anything that contains carbon. And the reason it is used is because the half-life it's 5,730 years. So after 5,730 years, it will take to 100 grams of carbon-14 to decay to 50 grams. After another 5,730 years, those 50 grams will decay to half of that, so that will be 25 grams. And after another 5,730 years, those 25 grams will decay to 12.5 grams. And so here, if we add the years that we have here, we have more than 1,700, or 17,000 I meant. So you could see why things that are very old are actually, their age could be determined or approximated. So in this problem, example 9, we're going to use the half-life of carbon-14. And the problem is about a round wooden table that allegedly belonged to King Arthur, who lived in the 5th century. So those will be the years from 401 to 500. Yes, the 5th century. So the table was shown to have lost, it had lost 9% of its carbon-14. And so we're going to use the formula that we have here. We could use either 0.5 or 1/2 for the number that goes here, which we call the base, because that's what is being raised to the exponent. So f of t is equal to the initial value times 0.5 to the power t over h. So let's define each of our variables, or write down the number that we have. So t, well, first the question is how old is the table? So t is equal to the unknown variable. H will be the half-life of carbon-14, which is 5,730. And we have the initial value, which in this case, it was the value that it was found to have. So let's assume that you have 100% of carbon-14 at some point. So if the table was found to have lost 9%, it will be 100 minus 9, and that will equal to 91%. So if we turn that percentage into a decimal, it will be 0.91. So that is going to be the initial value that we're going to work with. So that is all we need. And I'm sorry, in this case, we're not going to call this the initial value, but this will be the f of t. The initial value will just be the initial value, y sub 0, and the one here, f of t, will be 0.91, because 91% of the original amount, which is here. So what we're going to do is substitute f of t with this part, 0.91 times the initial value. So on this side we have 0.91 y sub 0. Then here we will have y sub 0 parentheses 0.5 parentheses, and then in the exponent, and make sure you do type that in the little box, or if you don't, you have to use the caret symbol, make sure you enclose that in parentheses for the exponent. So we will put the number there, t, which is actually what we're trying to solve for, divided by h, which is the half-life of carbon-14, 5,730. Now the first step we're going to take is to divide by y sub 0. We could do that on both sides. So we see that it will cancel on both sides because they equal to 1. And we'll have 0.91 is equal to 0.5 to the power of t divided by 5,730. So what we're going to do now is take the natural log on both sides. Remember, this is 0.5. And then we're going to use the power property that says that we could take the exponent to the front of the logarithmic expression. And so it will be t divided by 5,730 multiplied by natural log of 0.5. That's what we have so far on the right side. And on the left side, we'll have the natural log of 0.91. Now we could see here that t is being divided by the 5730 or 5,730. So if I take that quantity across, it's going to be multiplying on the left side. So this will be 5,730 multiplied by the natural log of 0.91, this part here. And then on the right side, I'm going to have t. And also what I'm going to do with this natural log of 0.5, since it is multiplying to the t on the right side, once I take it across the equal sign, it will be dividing. So I'm going to write it down here. Natural log ln of 0.5. And if you enter all of this in the calculator, you're going to get approximately 779 with 63.63. So we could round this and say that the time or the years of the table, the age of the table, will be 780 years old. And so, because of that, we will say that it could not have belonged to King Arthur. So, last problem of this section. Another application of logarithmic functions is the Richter scale used to measure the intensity of an earthquake. So